Let's prepare on theories of failure. So there are 5 theories of failure. Okay, so that 5 theories of failure, and for what this has to be considered, and what is the shape of the failure that is happening. So these are the things we'll be studying for all these 5 theories. Okay, so before going into this, why we are studying this means when an element is subjected to any load or any stress, how it is failing. Okay, so whether it is failing by brittle or it is failing by ductile, so that has to be studied. Okay, so based on the behavior of that material only, the design has to be altered so that we make that structure to be safe. Okay, so first, what is brittle and what is ductile means we know it already. So when the yielding happens, so like an elastic deformation, no, so that we call as the ductile materials. And when there is a fracture, that is when two parts are breaking up suddenly, means we call it as the brittle material. Okay, so the percentage of elongation, this we already studied in the first unit. The percentage of elongation is less than 5%, means we call that material as brittle. If it is greater than 15%, so that the elongation is more, means we call that material as ductile material. Okay, so now let us go into these 5 theories of failure. So the first theory is the Rankines theory, which is also called as maximum principal stress theory. And the second one is the Rankines theory, which is also called as maximum principal strain theory. And third one is Trescas or Gusts theory, so which is called as maximum shear stress theory. And fourth one, Higgs theory, total strain energy theory or maximum strain energy theory. And the fifth one is von Mises theory, which is shear strain energy theory. We can call it as distortion theory or Henke's theories also. Okay, in these 5 cases, the first 2 is purely for brittle materials only. Okay, so you cannot use it for ductile material, so that is the limitation for that. And the third and fourth, that one is for ductile materials only. Okay, so now let us see what is the assumption, what is the conclusion of these theories like that. So the first theory is the Rankines theory. So this failure occurs when the maximum principal stress is greater than the yield stress. So when this condition occurs only, the failure will be happening. So this is suitable for materials which do not have distinct yield point, that is brittle. Okay, so this is suitable for that brittle material only. For example, cast iron they have given. Okay, so here sigma 1 is less than or equal to sigma y by factor of safety. So all these sigma 1, sigma y and all we have already seen. No, so it is just the principal stresses in that element. Okay, so normally we'll be drawing the diagram like this, no, x-axis, y-axis, and the element will be like this. Okay, so here this horizontal axis will be sigma 1, and in the vertical sigma 2 will be acting. In some cases sigma 3 will be the third dimensional stress also. Okay, so in this case sigma 1 should be less than or equal to sigma y. Sigma y is the yield stress of that. So based on this theory concept only, they have derived this formula. Okay, so knowing this formula and knowing for which it is suitable, this both are enough, and knowing the different names. Okay, so the Rankines theory is also called as maximum principal stress theory. Okay, so these 3 only are very important in these 5 theories. So this only they will be asking in the exams. Okay, so now we can go for the second one, that is Rankines theory. So here the failure occurs when the maximum principal strain becomes greater than the yield strain of that material. Okay, so here the strain should be less than the yield strain. So it is derived as sigma 1 minus mu sigma 2 less than or equal to sigma y by factor of safety. And the shape of that yielding locus, no, that is rectangular for the first case. Okay, so we call that as the yield surface, or you can call it as the yield locus also. So as I draw first, no, so here if this is the case, means the yield surface will be like this for this Rankines theory for the first case. Okay, so this is the rectangle shape, so this shape is also important. For the second case, that is for Rankines theory, it is parallelogram shape. Okay, so it will be like this. The failure will be occurring like this. So this is a parallelogram shape for the Rankines theory. The third one is the Trescas and Gusts. So here failure occurs when the maximum shear stress is greater than the shear stress at the yield, that is the yield shear stress. So here tau max, that is maximum shear stress, should be less than or equal to tau naught, and the equations are derived like this. So it is the final equation is sigma 1 minus sigma 2 should be less than or equal to sigma y by f of s, that is factor of safety. Okay, so here the shape of this yield will be in a hexagonal shape, so it will be like this. Okay, so it will be like this. So it is in a hexagonal shape. And the fourth one is Higgs theory. So here when the failure happens means the total strain energy becomes greater than the strain energy on the yield stress. Okay, so here this is the formula: root of sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 mu sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 3 sigma 1 should be less than or equal to Fy by factor of safety. So here the yield stress or the yield locus will be in an elliptical shape. Okay, so if it is like this means the shape of the yield will be happening like this. And the last one is the von Mises theory. So it is also called as distortion theory or Rankines theory. So here it is just a summation, that is the total strain energy should be the summation of volumetric strain energy and the shear strain energy. So only that is considered here. And the condition here is given as root of sigma 1 minus sigma 2 the whole square plus sigma 2 minus sigma 3 the whole square plus sigma 3 minus sigma 1 the whole square divided by 2 should be less than or equal to Fy by factor of safety. Okay, so here also the shape of that yield surface for this distortion theory should be a ellipse only, which is same for the previous one. So first is rectangular, second one is parallelogram, and third one is hexagonal shape, and for the last two it is the elliptical shape. So this is the yield surface shapes that are occurring for this theories of failure. So this is all enough on this unit. So based on this only the objective questions will be asked here. With this, strength of materials is over. Thank you and keep watching for more lectures.